Hi folks, this is Nat, and this is going to be a video lesson on identifying keywords and phrases to help us figure out how to tackle different types of problems. We've talked a lot about different types of proportions and proportional relationships, and one of the problems students tend to have at this point is so many different types of ways you can use proportions, it's sometimes hard to figure out which one you're using. So we're going to be focusing in today on how we can figure it out by looking for keywords and phrases. So we're going to start by making a chart of the different phrases you might see in relationship to each of these types of problems. There are percent problems, there are unit rate problems, and we've recently talked about proportional relationships as well. Percents are going to probably by far be the easiest to figure out because it's impossible to talk about percents without using the word percent or the symbol for percents. So if you look really carefully in a percent problem, you will always find either that percent symbol or the word percent or maybe the word percentage. Again, it's really easy to spot these things because in a percent problem you have to use the word percent because otherwise nobody would know what sort of statistic you were shooting for. So when we see one of these three phrases, we know what we've got and we can set up accordingly. For example, here we go. Number one, you had 30% of the 25 puppies. How many did you have? Well, 30%. Key phrase right there. That tells me I'm going to start with 30% out of 100, and that can be my setup. What tends to give people more trouble with these is recognizing whether the other information, the numerical information, in this case 25, is the part or the whole. We can learn from some of the things we've seen with proportional relationships about how to make this easier. If you think about it, it's very similar. The numerators have to match up. So in this case, I have 30% of the puppies, so 30% is what I have, and whatever I put on the top has to be what I have. So 100% of the puppies is all the puppies, and whatever I put on the bottom has to represent all of the puppies. So when we look at this 25, we can say I have 30% of the 25 puppies. Maybe that's unclear. I can now go to the question and say, how many did you have? Well, if I'm asking how many I have, I obviously don't know the have portion of this. So the unknown value is going to be on the top. 25 in this case must represent all the puppies, if you couldn't figure that out from the context. And I'm ready to go. For today's lesson, we're going to skip the actual solving of these things and focus more on the keywords and the decoding and setting up. Number two, you have 7 out of the 18 items you need to bake cookies. What percentage do you have? Well, here's that keyword again, percentage. What percentage? I don't know. So this is a question about a percent. So an unknown percentage is X over 100, and hopefully 7 out of 18 items feels like a pretty manageable second half there. But again, if we look for those key words, percents are the easiest by far. If we see the word percent, we're probably dealing with a percent problem. Unit rates are a little trickier, but they do tend to have specific keywords in them. So for example, we really frequently see the phrase something per something. And those two somethings help make up our unit rate. So per is a big unit rate key phrase. Similarly, the word each also tends to indicate unit rates, because when I say each, it tends to mean each one, each single thing, which gets you to a unit rate. The other one you might see is just the word one. How much would one person have, or how much would one something do, or any sort of question involving one might indicate a unit rate. So here are a couple examples of this. Number 3, there were 56 blueberries for each person. How many blueberries would there be if there were 18 people? There are some shortcuts here, but the first thing I'm going to point out is this word each. Each is 1. So each one person. So here I can tell I've got a unit rate. There were 56 blueberries for one person. 56 blueberries, one person. How many blueberries would there be if there were 18 people? Now, just like we've talked about in the past, our units have to match up in proportions, proportional relationships. So 56 was blueberries, 1 is people. Here I've got 18 people. That's going to go on the bottom, and I can be done. Next one, number 4. You saw 90 yaks in 4 minutes. How many yaks would you see in 1 minute? Well, the first thing I'm going to notice is this number 1. Unit rates are always out of 1, so again, that's a clue that this is a unit rate problem. The question is yaks in 1 minute. Yaks in 1 minute. And I just have to set the other side up the same way. Yaks on top, minutes on bottom. So 90 yaks in 4 minutes, and I'm done. So we watch for those unit rate phrases. It can make life a lot easier. Finally, we have proportional relationships, which we've talked about recently. By far, this is the one that has the fewest kind of specific keywords. If you're going to see one phrase or one idea that would be the best clue, it's probably the word rate. And we'll take a look at an example of how that's used in a second. The other thing that frequently comes up in proportional relationship questions is not a specific phrase, but the idea of expectations. We're asked oftentimes to tell what we'd expect or make a prediction based on information we have. And while we're not specifically told that this is a proportional relationship or something's happening at a specific rate, if we're making a prediction or basing that prediction on expectations, we're probably going to have to assume that things are happening at a specific or continuous rate. So again, here's some examples. If you ate out 5 times, this is number 5, if you ate out 5 times in 2 weeks, how many times might you eat out in 7 weeks? There really isn't an obvious key word here. The thing that I'm going to point out to you is this word might. Might is a word for making a prediction or giving an expectation. It's sort of like asking for a guess. And since we don't have enough information to know for certain, we're just going to have to use the information we already have and kind of assume that it's at a consistent rate. So if you ate out 5 times in 2 weeks, 5 times in 2 weeks, maybe that's proportional to the number of times you'd eat out in 7 weeks, and we'll just set it up that way. So we have to keep units the same, 5 times 2 weeks. So 7 weeks will go on the bottom with 2 weeks, and the number of times I eat out is going to be unknown. Number 6 is a little bit easier in terms of finding keywords. It says you traveled 800 miles in 12 hours. At that rate, that jumps out at me. At that rate, how many would you expect, there's another good word, to travel in 17 hours? So both these ideas are telling me that I'm establishing a specific rate of 800 miles in 12 hours. So I'm going to set this up as 800 miles in 12 hours. And the question is, how many in 17? So again, once I know that I'm dealing with a proportional relationship, I just got to get my units matched up. I've got miles on top, 800 miles, and hours on bottom, 12 hours. So this 17 hours is going to go on bottom with the other hours. Miles is unknown. So the thing I guess I'd like you to focus on most here is that there are kind of phrases and keywords that you can really look for. We've learned a lot of different types of problems involving proportions, and it can certainly get confusing which one you might be dealing with. If that's a problem you have, try to focus in on these keywords and it'll help you out a ton. So here's some practice problems for you to work on. You do not have to solve these problems. What I want to see is actually the setup. So if you make a proportional setup, that's plenty. If you feel like going ahead and solving them, that's fine too. But again, we're focused on the setup here. So look for some keywords, figure out what type of problem you're solving, and show me the correct proportional setup. Good Good luck.